Good morning again, everyone. Glad to see you all. I hope you enjoyed so far the conference and the sessions. Immediately, we're going to start a very interesting panel discussion called Origins and Destination Beyond Midjourney. So we've invited a couple of colleagues and also industry figures who have contributed to some of the tools that have been picked up by many of you probably recently, to have a really interesting conversation between the designers and the developers. So to give you a different perspective. I'm going to introduce the guests for this panel. Chigozie Inri is writing tools to help generate art in collaboration with AIs. As a developer at Stability AI, Chigozie is one of the contributors to the development of a Stable Diffusion, a machine learning text-to-image model to generate digital images from natural language descriptions. Prior to working with Stability, Chigozie was a central contributor to a preceding diffusion model, Disco Diffusion, and was a resident at a Scholastic lab at Berkeley. Previously, she worked as a scientific software developer at NTOUT in Cambridge, where she studied molecular and life sciences through hardware and data processing, and also as a lab automation engineer at New Age Meats in San Francisco. She studied bioengineering at Caltech and holds a Bachelor of Art and a Master of Science in Natural Sciences from the University of Cambridge. Welcome, Chigozie. Move to the next guest. Joel Simon is an artist, toolmaker, and researcher. His experiments and artworks are motivated by the emergent systems in nature and creativity and their interaction. Some of these experiments have grown into popular creative tools, and he is now the founder/director of Morphogen, a company based on these ideas and that turns new machine learning technologies into playful and accessible creative tools. Notable among these tools is Art Breeder, a collaborative machine learning-based art website based on StyleGAN and BigGAN, which this tool and its predecessors, GAN Breeder, were among the first to bring machine-generated imagery into the public imagination. Joel is currently a resident at a Stochastic lab at Berkeley. Previously, he worked as a bioinformatic researcher at the Rockefeller University in New York and studied computer science and art at Carnegie Mellon. Welcome, Joel. And we have our colleague here, Kyle Steinfeld, who writes and teaches about computational design as a cultural practice, an associate professor of architecture at UC Berkeley, who aims to reveal the overlooked capacities of architectural computation through related practices of creative work, scholarly writing, and digital toolmaking. As an educator, Kyle has instructed core courses in design, architectural representation, and design computation for more than 20 years. His leadership roles in the College of Environmental Design have included serving as the Associate Dean for Undergraduate Studies and as the Associate Director of the Master of Design program. Kyle holds a Master of Architecture from MIT and a Bachelor of Degree in Design from University of Florida. He's a fellow at a Stochastic lab again. I apologize for the first mistake I made. Labs at Berkeley, and Autodesk ACADIA follows in San Francisco. And he's a Hellman Fellow. Welcome, Kai. So, I'm going to move to this slide. I have no doubt that every single of you, including myself, that there would be a single day that you open your phone or go to your social media and have not seen images like this. It's quite psychedelic, it's very interesting to watch, and they will take you to a completely different world of imagination, I would say. I'm taking these images from particularly one of the websites, well, not website, but the works of one of our colleagues, Andrew Kudlis, who has done amazing work actually in this field. And he's here. I can't see Andrew. Yes, Andrew is here. Please join us for a panel today. He's going to be part of that really, really interesting discussion. I couldn't find better examples for the discussion we're going to have here. And I've selected one particularly to show you that this image alone has received 175,000 likes. That's unbelievable. So it actually tells you something, that there are many, many people, either architects, engineers, designers, regular people who have no background in design, can communicate with these ideas or basically relate themselves to these spaces created. So with that, I would actually refer to this quote that Sanford Greenfield basically mentioned in his preface at the Architecture and Computer Conference in 1964. And he says, and is basically directing that to the effect of computer and its upcoming impact in the field of architecture, that alert the profession to an irresistible force which will radically alter the practice of architecture, whether we plan for it or not. And in that conference, obviously, the opening statement was by Walter Gropius, and people like Marvin Minsky, Stephen Koons, Yvonne Sutherland, and William Fetter, who became the figures of artificial intelligence, basically attended that conference. So it is an important matter, and that's the reason that we are basically getting together to discuss that among ourselves, to see where this is going to take us. And it would be great because now we have some really main figures who've contributed to the development of these tools as scientists, sitting in front of you so you can have a direct dialogue with them. We've also arranged something particular for this session. There is a website called Slido. You can go to that website and enter the code #ACADIA. So that allows you to ask live questions, and then Kyle and myself are going to select from those questions in the panel and ask it. So feel free to use that tool to communicate with our renowned speakers. All right, I'll invite Kyle to join us to give his introduction, and then we'll follow by Joel's presentation. There will be a very short discussion afterwards, and then we will move to Chia and her presentation, and we would close the session. Thank you.
While we're switching over, I just want to take a moment to thank the organizers of ACADIA for putting this panel together. It's something that came up rather suddenly in the summer in response to, of course, a particular cultural action out in the world. And I also wanted to say that I really hope, my motivation in planning this was to bring together the ACADIA community, designers and architects, with folks like Joel and Chia into dialogue. I think it's a very important moment to do that. And that's why we're motivated with this kind of Slido thing. We want to seriously engage with the audience in deep discussion. So it won't be a panel discussion where we're kind of talking amongst ourselves all that much. We'll do a bit of that, but we really hope to engage with y'all in the audience. One last note, if you're watching this on the live stream and you ask a question via the Slido, please let us know that you're not in the room. We'll still address your question, but we won't ask you to read it, obviously, because you're not here. So, I'm going to start with a bit of history. And if you'll indulge me, it's sort of situated as a rather long introduction to these two folks. Not long as a talk, but long as an introduction. But I think that the kind of the context in which this phenomena that happened over the summer occurred, I think, is an important way to frame the beginning of the conversation. I think we might all agree that if there's a single idea that describes the ethos of a technology industry on the west coast of the US, it's disruption. As a computational designer working close to Silicon Valley, it can feel at times that architects are the passive recipients of technologies that are developed elsewhere. It can feel like our job is to wait and see what those people down there in the valley are up to, and then help the discipline cope with the aftershocks of whatever fresh disruption they come up with next. I'm glad to say that I've recently had the chance to get to know some of those people, and I'm glad to bring them here today. Joel, Chigozie, and I were a part of a residency program hosted by Sarcastic Labs here in North Berkeley that was focused on ML-based creativity support tools. I've worked alongside developers of creativity support tools in the past, different kinds of software. I can say this is a very different sort of experience. They're a remarkably thoughtful, brilliant, intellectually challenging group. And working in this beautiful Victorian was a very different experience than, say, my residency at Autodesk, for example. And the food was better, I have to say. So as I'm sure we're all painfully aware, broadly speaking, and with notable exceptions, the software used by practicing architects is not typically developed in beautiful California Victorians, and often not developed with our discipline in mind at all. But it's adapted from tools that are developed for other contexts and from systems designed for larger markets than ours. Most of the time, these technologies seep into our world in a kind of trickle, giving those of us who work in design technology plenty of time to reflect and prepare for what changes this technology transfer might bring. At other times, something hits us like a rock from the sky. And the summer of 2022 felt like it was one of those times. As Masoud showed us, the summer of 2022 saw an explosion of synthetic architectural images produced by any one of a series of text-to-image generation tools that were released one after another in a span of just a few months. DALL-E and Midjourney might be the most well-known to designers sitting in this room, but there's others. There's Stable Diffusion, there's Image Gen, et cetera, et cetera. So what led to this? Why did this happen? Despite appearances, diffusion models, text-to-image models, they're not sorcery, but they're tools produced in a specific socio-technical context. So while the impact of Midjourney, DALL-E, and Stable Diffusion and others might feel like a rock from the sky, the tools themselves are not extraterrestrial in nature. They did not emerge fully formed in the vacuum of space. Rather, the events of this past summer were rooted in a particular social context and arose out of a specific technical history. So the idea for this panel arose out of the need to address exactly this. Here, on the steep incline of yet another hype cycle, this is precisely the right time to begin to demystify the object of the hype and dispel some of the magic, the sense of magic that kind of surrounds it. So to help us to understand what led to the summer of 2022, and also to serve as a kind of extended introduction to our panelists, I'd like to start with this short history. This is a look at the socio-technical forces that led to this moment. I'll look at 3 moments in time. These will be familiar moments for those of us who are familiar with the history of AI, who work in ML and design. The first is the middle of the last century, the 1950s, 1960s, somewhere in there. The second is the turn of this century, the 2000s and 2010s. And third is, speaking to the speed at which this technology develops, the events looking at only the past 18 to 20 months. Across these 3 scales, what should we look for? What do we understand as being important? So in each period, I'll look specifically at 3 factors. First, there's the technology itself. There's the kind of both the hard tech, that is to say the algorithms, the architectures, the models, the data formats, et cetera, as well as the domains. What I mean by that is, what are the problems that AI researchers and others seek to address? What do they see as their audience, and how do they see their work entering the world? Next, we'll also look at the social context in which this technology was produced. That includes public and private research institutions, informal online communities, social networks, creative collectives, all of which kind of come together to support AI research and creative machine learning in ways that are a little bit surprising. They might not be what you expect. And finally, we need to look at the infrastructure and the access that makes this activity possible. This includes all those tools, resources, software, platforms, programming languages, hardware accessibility, et cetera, that's required for the other activities. Something I'm leaving out here in the interest of time, but it's on my mind, are the practices, the creative practices that intersect with all of this other work across the 3 timescales, influential creative works, aesthetic theories, cultural events that expand the space of possibilities in creative ML and expand the kind of popular imagination of these things. I think it's important, but we don't have time. Why do we look at these things together? It's because technologies, infrastructures, social structures, creative practices, all of these things are intimately interlinked. There's layers of dependency at work here, far more than I have time to pull back in the space of this talk. But let's give it a go. Scene 1. The field of AI developed in the 1950s, proceeding through the application of a, quote, systems theory model of human cognition as the basis for machine logic. In what became known as the connectionist approach to AI, some of the earliest work in the late 1940s and 50s used connected circuits to simulate intelligent behavior. Notable among these early models was the concept of the perceptron, which we see being invented here, which was a classification algorithm first invented in 1943 and first implemented as a physical machine in 1958 by Frank Rosenblatt. Early AI research was, of course, far removed from practical application. While advocates would extol the potential applicability to a range of problems to an academic audience, the work was not propelled by academic interest alone. Of course not. Rather, it was supported by in relationship for its promising applications in national defense in particular. For instance, at MIT alone, which we see pictured here being covered in money, ARPA, later DARPA, contributed $2 to $3 million per year to AI research from 1963 to the mid-1970s. This money was provided with very few strings attached and contributed to what has been termed a technological libertine atmosphere at MIT at the time. This was an atmosphere that's strongly related to what we would now call hacker culture. For more on this, please see Sherry Turkle's work, The Second Self. This hacker culture grew into and spawned in many ways kind of cultures that exist today and that current technologies are growing out from. So spoiler alert, I highlight the perceptron here because it's the great grandfather of modern machine learning systems. It also figures large at both the start and the end of this early period, as connectionism was abandoned in favor of symbolic reasoning approaches. This was late 1960s, early 1970s. Turns out that connectionism was just one school of thought in artificial intelligence. A turning point in this early period was when Marvin Minsky and Seymour Papert wrote a book in 1969 on perceptrons, which described their view of the limits of neural networks in AI and offered a criticism. This criticism contributed to the first of the two AI winters, pictured here, which are periods of diminished progress in AI. These are kind of quiet periods. They had less to do with a natural progression of technological advances and really more to do with AI's, quote, visibility or invisibility, borrowing from Neil Leach. That is, cycles of public and private investment respectively driven by either popular interest or the expectation of marketable outcomes. So I wish I had time to describe how the technological milieu of AI at this time intersected with the creative and architectural world. Instead, I'll refer to Molly Steenson's excellent work on architectural intelligence for an account of this early period and its intersection with architects, architectural thinking, including figures such as Christopher Alexander, Cedric Price, Nicholas Negroponte, and others. A quick summary, mainly to kind of lay down a groundwork for how we'll look at each of these periods. Technology. So technologies were developed in this period that formed the foundations of the connectionist approach, neural networks, right? Applications domain included things like machine translation, natural language processing, reasoning as search, and others. All of these held application to national defense. The social context in which this happened, of course, as you would imagine, was in research conducted in academic labs at R1 research institutions. The funding was dominated by government grants, usually often military related, with limited private money in this space at the time. When I talk about infrastructures and access, I'm looking for who has access to the resources necessary to make contributions at a given time. At this period of time, you needed big computers, usually made by IBM or someone like that. They're very expensive, so access was limited, and it was restricted to the social context that I described. I'll use the same sort of way of looking at each of the three periods. Let's move on to scene two. We jump forward now 50 years to the early 2010s, maybe the 2000s, something like that, leaving aside an inexcusably large body of important history in the interest of a relatively short presentation. So suffice to say that the AI winter of the late 1970s that I mentioned before led to an AI summer in the mid-80s, which was propelled by other factors and infusion of funding from the Japanese government, and this was followed by a second winter in the early 90s, and then a thaw. This most recent thaw was preceded the springtime that we're currently enjoying, and also reestablished connectionism as the dominant tribe in AI. Again, none of this technological development occurred in a vacuum. Lots of things changed across this 50-year span, as you would imagine. Two major changes were relevant to this discussion. Number one, computers got faster, as we all know, both in terms of general processing and dedicated graphics processing. And this was important, but what was more important was the world started producing and storing vastly more data. And the second point is the crux. Across the first decades of our current century, access to large amounts of data and cheaper computation to store and process this data, this radically transformed the global economy. The expansion of computing power and resources was off the charts, right? To illustrate the scale, let's look at this. In 1997, so just before this time period, computer scientist Michael Lesk estimated that there was, quote, a few thousand petabytes of information in the world. Now he's talking about petabytes of information in the world, not stored on computers, but rather in the world, like total human-produced information. And he predicted that the data storage would match this capacity by the year 2000. So by the way, a petabyte is 1 billion gigabytes. So that's the dot on the left. He also predicted that most of this data would never be looked at by people. He was right about that second point. He was wrong about the first point. In 2011, in contrast, McKinsey, which is the middle square, McKinsey Global Institute estimated that there is 13 exabytes of new data being created and stored by companies and consumers every single year. So the left dot was an estimate of how much total human data there is. The middle dot is what was being produced only in 2011 as an estimate. Let's see, is an exabyte, 13 exabytes, that's 13 billion gigabytes. The volume of data produced today, at least 2021, is estimated to be around 94 zettabytes. 94 zettabytes is 94,000 billion gigabytes, the square on the right, every year. So, a lot more data. What does this mean? We know that this is like a well-known and well-studied story, right? It involves the transition from technologies that were propelled by the need to address wartime logistical problems, transitioning into technologies that were propelled by the need for governments and private interests to more effectively sift through a steadily increasing volume of data, that giant black square on the right. Data about people. That is to say, a transition of technologies of war to technologies of mass surveillance. So the problem of big data, which is what we called this in the early 2000s. And the perceived opportunities for surveillance and for commerce provided the motivation and the justification for a series of technical innovations and new funding structures that characterized this period. This, in turn, set the stage for the period that we're now enjoying now, the current spring, and we can't separate these things. So again, a summary of this period to help us compare it to others. On the kind of hard tech, kind of foundational technology side, a range of technologies were sort of quietly developed in the 80s and 90s, applied in the early 2000s, that refined and extended neural networks, enabling the widespread application of different forms of machine learning to practical problems. These included CNN, convolutional neural networks, backpropagation, autoencoders, blah, blah, blah. To support this development, if we look at infrastructures, a number of pieces were needed. First, foundational data sets are established to support machine learning research in a relationship to newly identified domains of application. These are usually established by academic institutions. This is also the foundation of what we would now call the cloud infrastructure, making high levels of GPU compute accessible, but mainly not really going out into the kind of broader public, but this was a kind of established foundation. AWS, Amazon Web Services, Google Cloud Platform, et cetera. If we look at application domains, there's a very different valuation for what an AI would do in this period. They're valued for their commercial application and sifting through large amounts of data, as I've mentioned. So these include techniques like image search and handwriting translation. Banknote translation was one of the first big marketable applications of AI in this period. But they're also valued for their visibility and sort of marketing purposes for big tech firms. So when Deep Blue beats Kasparov, we all think about IBM, right? When AlphaGo beats Lee Sedol, we all think about DeepMind. So these events are intended to shape public perception more than be kind of practical technologies. Turning to the social context that supports this development, things looking a little bit different than the previous period, and we see some groundwork being laid for something that's very different that's happening right now. Academic research labs have expanded now and proliferated, Oxford, Stanford, MIT, et cetera. Everyone's got an AI lab now. Private research labs are newly established. So this is a period when big tech firms like Google and Microsoft developed dedicated AI research groups. Much of that was propelled by a revival of government funding, of course, which still provides the bulk of support for basic AI research in academic settings. But we begin to see a kind of private backing of ambitious, quote, moonshot AI research that are happening in places like big tech, Facebook, Apple, Google, et cetera. So as a way of transitioning to the final scene, and I can't believe that I've gotten this far through a talk on ML and creativity and I haven't shown these images yet, I have to mention these two developments, Deep Dream in 2015 and the invention of the GAN in 2014. These are both well-known in the ML community and perhaps to this community as well, I think. Had a huge impact technically and culturally and drove generative aesthetics from 2015 to 2020, just before the period that we're in now, and enabled a large range of artists, too many to mention here. So I regret not being able to talk about this more, but it's time to go to scene three. Scene three, our current springtime. So here I'm going to talk about the past 18 months, just the past 18 months, that have brought us Midjourney and all the rest. This came about because, of course, a specific social and technological context that I described both in the previous scene, and I'll describe a bit more here. It's a period that's marked by a level of accessibility to these technologies, the technologies that drive these tools, that's nearly unprecedented. In the intervening 5 to 10 years from the previous scene, emphasis has shifted from theory to applications, from developments in foundational technologies to developments in infrastructures that provide greater access. So the establishment of these infrastructures, this holds a deep impact on the social production of creative work. Infrastructure I'm talking about here is like the availability of published models, the open source architecture, the publishing of an architecture for a model, the publishing of weights for a trained model that lets you actually work with it, and access to compute, which is also greatly expanded across this period. All of this has enabled, quote, non-affiliated research labs, that's now a thing, and empowered, quote, casual technologists. These are both sort of new things in the world, I think. They have some history, but anyway, this change has empowered both of these sort of entities to make real contributions that hold wide impact. So innovations are not just happening with the big players anymore. So this is where we finally meet our protagonists and who I'm introducing. So the tools and the work that you're about to see, presented by our two panelists, Jill and Shia, these are a direct product of a series of technical innovations in a social context that might be a bit unexpected. So take, for example, the non-affiliated research labs. One of these is called Eleuther AI, which is a, quote, non-affiliated deep learning research lab founded in July of 2020. It's self-described as a, quote, decentralized collective of volunteer researchers, engineers, developers focused on AI alignment, scaling, and open source AI research. What does this look like in practice? It's a bunch of unpaid knowledge workers collaborating on passion projects and organizing their efforts on Discord. That's what an organization like this is. It's not a company, right? It's a passion project. But organizations like this have made serious contributions in the open source re-implementation of published research, in the maintenance of important large data sets, and in the invention of entirely new architectures, all done outside of an academic lab or outside the context of a large tech company. So in this period, we find that innovation is no longer the provenance of large academic institutions and closed corporate labs. A number of, quote, clever little tricks are directly responsible, or cooked up by these independent actors, are directly responsible for the events of 2020. So it's better at this point to depart from our chronological story and shift to an instrumental one. The diffusion models that are the subject of this panel are an amalgam of technologies, each holding its own separate provenance. So let's take the diffusion model apart, it's not that complicated, and conduct a very brief biography of the constituent elements. The core technical elements to contemporary text-to-image tools are right there in the full name of the technology. Clip-guided diffusion is the full name. So this is an amalgam of two systems. On the one hand, you have diffusion. This is the part that's responsible for the composing of synthetic images. Diffusion was developed between 2015 and 2020, primarily in academic labs, specifically Stanford and UC Berkeley, in a fairly open source manner. On the other hand, you have Clip. Clip is responsible for guiding the diffusion process towards an image that matches a prompt. So Clip understands the relationship between images and text. This was developed in 2021 by a private research lab, OpenAI. OpenAI released both the architecture of Clip, which are kind of like the blueprints, but not the building, as well as the weights for the trained model itself, which is like the building? I don't know, my metaphor's falling apart. They released both of these things in January of 2021. And that event was pivotal into the things that happened this past summer, the release of the architecture and the model for Clip. A cascade of things happened. So I should mention, these were both, so I'm going to go through a series of sort of small experiments that eventually lead us to things like Stable Diffusion, Midjourney, et cetera, which were conducted by these sort of independent actors noodling around with the tech. Each of these was not the kind of first of their kind systems. The modern approaches to text-to-image synthesis actually started in 2016, but these were the first to find sort of real success. So let's begin. January 2021, this is a week after Clip was released, or something like this. The first person to connect Clip to an image generation function, outside of OpenAI, of course, was Ryan Murdoch. He is a self-taught ML engineer, a bachelor's in psychology from the University of Utah. Later joined Adobe to work on neural filters, and here he's using Siren, which is a generative model, to make images in connection to Clip. So Clip-guided diffusion, this is not Clip-guided diffusion, it's Clip-guided something else that makes images, but it's the first of its kind to do this pretty successfully. That's an example of an image that it made way back when, in January 2021. He also put together this another machine called Big GAN plus Clip, also called the Big Sleep. This is the first time that Clip was connected to a GAN. Also, Ryan Murdoch uses Big GAN as the model. February 2021, a project called Aleph to image. Also Ryan Murdoch. This one basically takes apart DALL-E, which was published by OpenAI, but here he's only using the image generation part, the variational autoencoder, to make images. So lots of sort of noodling around and things are getting better and better. This was a pivotal moment as well, June 2021, VQ GAN plus Clip. So now we're attaching Clip to a different kind of GAN. This was Catherine Croson, aka Rivers Have Wings. And this was one of the most widely forked sort of X plus clip image generation systems out there. Importantly, this also led directly to a project called Disco Diffusion. And this basically adapted Catherine Croson's work into a Colab notebook. I'm not sure if everyone knows what a Colab notebook here, but it's actually a critical piece of infrastructure, so that lots of people could contribute to the development of this thing, and lots of people could use it. Contributions include Daniel Russell, who's now at Midjourney, Max Ingham, who's now at Midjourney, Adam Letts, who's now at Stability, Chigozie Inri, who's now at Stability, and a whole bunch of others. So the companies that we know and we know so well arose out of, they're hiring people out of this kind of creative community that's experimenting in this way back a year ago in October 2021. Okay, so in summary, in 2021, a bunch of people released a bunch of Colab notebooks that make psychedelic art in clever ways. Why is this important? Well, it turns out all of these text-to-image tools that are the subject of the panel, DALL-E 2, Midjourney Stable, ImageN, all of them are a direct product of these sort of clever little tricks that are developed by the people that I've just mentioned. They developed it by passing around Colab notebooks, by collaborating on Discord, and by bragging about all of it on Reddit. So, seeing this recent history through the lens of our analytical framework lets us clearly see how the current moment is so distinct from all the others that I've talked about. I've already talked about the specific technologies developed recently that catalyze the burst of interest in text-to-image architectural circles, clip, diffusion, GANs, etc. I've also already described the infrastructure that enabled the widespread access required to make such advances. Google Colab and GitHub for distribution, cloud infrastructure for access to compute, Discord for collaboration, Reddit for bragging. These are all the parts that you would get at in an academic setting or in a big company, a big tech company, but they're out there in the world and they're being done just by people. The social context in which these advances took place was largely established in the previous time period, but they're worth emphasizing again. We find the usual institutional players here, right? So big tech labs like Google and OpenAI, academic institution, Berkeley, LMU Munich, Stanford, etc. All of these are important because they're developing the core pieces, but then those pieces are being assembled in different ways by sometimes non-experts, sometimes amateurs. We also find independent labs, nonprofits, and community-driven efforts like eLuther, which I mentioned before, and Stability, kind of community-driven. So if you take away just one thing from this introduction, I hope it's this. We live in exciting times. It's exciting not because these images are beautiful, I think they are, or that anyone can make them, oh, that's cool, but because creative machine learning has never been more accessible than in this moment. In the very recent past, which I've covered, big, important contributions have been made, not only by large institutional players that you might expect, but also by communities of creative practitioners, not so different than the people that are in this room. And by that, I'm talking about these two. I'm also talking about y'all. Right? We have the capabilities in this auditorium to make contributions in this space, and that's very exciting. On to the two people I'm supposed to be introducing right now. So these two folks are not traditionally credentialed. Neither has a PhD in machine learning. The most impactful lines in their resumes have nothing to do with a big tech company, right? Joel and Chia are emblematic of the shift in the socio-technical landscape that I outlined in this talk. A shift from not really big to small, but like big to different, right? Joel, as Masood mentioned, made GANBreeder. He made that in 3 days while sitting at a coffee shop on 28th Street in Manhattan. Chigozie contributed to Disco Diffusion, the immediate processor to Midjourney and similar, not as an employee, right, but as a member of a creative community because she wanted to, right? So I would suggest that we approach our conversation today as something like an oral history. Each of our guests can literally bear witness to the recent and upcoming shifts that will significantly impact the way in which architectural image making happens, which is, of course, an important part, not an entire part, but an important part of architectural practice and education. And it holds an outsized influence on the architectural imagination, I would argue. So with that, I'm so excited that you guys are here. Please join me in welcoming Joel Simon and Chigozie Inri.
Cool. So, okay, today I'm going to be talking about creative tools based around generative methods. I'm going to be offering a kind of critique of the primary paradigm, which is text to image, talk about its limitations, talk about the work I do in this area to make this technology accessible, and hopefully in doing so, build up some, or poke around at, where this tech and where these tools may be going and how they may be affecting us, as creative people. And so just very briefly, I come not from this world. I come from, generative biological art and simulations, genetic algorithms. I've done work in kind of like emergent phenotypes, corals. I've done some work in kind of biologically inspired floor plans. And so I came into this world interested in how I could turn these generative methods into tools, things I feel like I have in my hand, and turning technologies into actual tools. And I run a company called Morphogen. So today we're going to be talking about text to image, which I'm assuming most of you have heard of or seen on Instagram or seen around. But it's basically exactly what it says. It takes some text and it does its best to render it into an image. So a tree is a human too, and it will do its best to do that. And this is, it's weird, it's wonderful, it's a lot of fun, it's stimulating, it's super cool. You can type in something and then these incredible images kind of arise. And we've seen it be really resonant and, for a lot of folks who think of themselves as people who can make imagery. So it's not to say text to image is bad, but I just wanted to kind of discuss a lot of its limitations, particularly because it is kind of the dominant methodology right now, and a lot of people see it as like what it means to create with machine learning right now. So just give like a very basic example, like this is with DALL-E, one of the leading methods. If you ask it to create a blue cube on top of a red cube besides a smaller yellow sphere, it does pretty poorly, and that's not really that hard of an image to make. It's a very simple composition, and already you can see it's starting to break down, and there's some really like fundamental limitations here. Like the data sets they're trained on are like images scraped off the internet with like a caption, and it can kind of do what those captions said, one or two objects, and as soon as you get to like more complicated arrangements, it can't really do anything specific. And more so, like, how would you actually describe a painting? Like think about, any painting you may find particularly compelling or sophisticated composition. Like, what would it mean to create this with text? Like, would you say, like, all right, there's 12 people. On the far left is this one, to the right of them is this other one, and then the right of that person, and this person is this colored shirt, that person, you could clearly see that, like, there's an incompatibility between these two. And I guess what I'm getting at here is kind of like this fundamental assumption that text and imagery kind of occupy the same world. And that for compositional, for color, text has some very like innate limitations. And here's kind of another example, of course. What would the prompt for this have been? How would you have made this with text to image? And so, we can use this tool called like clip interrogator. And what this does, it will actually look at an image and try to find the prompt that clip may have been made to make it. And we can see, all right, a black and white painting of people and animals by Picasso, blah, 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 cubism under artillery fire. And so clip interrogator trying, this is what we think the prompt is for this. And of course, this like, I think highlights some other kind of like major limitations. Of course, like Picasso wouldn't have been in his own data set when he was making it. So they're kind of these like cultural time capsules. And so you have to like know what the model knows. And of course, like the kind of full expressiveness of imagery is something that can transcend language. That's what's so evocative and powerful about it. And I love this quote by Wittgenstein that I think gets to kind of a similar concept. Uttering a word is like striking a note on the keyboard of the imagination. And how I interpret this is like language is as much an act that happens on the kind of like the receiving end as the person communicating it. And so language, in many cases, art is like interpreting language, interpreting ideas, and the act of expressing it into a visual medium happens not just in the text, but in its expression or interpretation. And kind of hear like a visualization of this. Like, if you have one prompt, each time you kind of roll the dice of this kind of like slot machine, you'll get a different rendering. And of course, like these are all within the bounds of what that one model thinks. And if you get another model, you get another domain of things. And so you're going to get something cool when you kind of like pull the slot machine lever, but are you going to be able to point at exactly what you want? No. So the kind of controllability of it is very limited to kind of expressing, more intentionality in kind of the creative process. And, people talk about like natural language. The prompts often look like this, or I call like unnatural language interfaces. You may have seen these kinds of like spice words before in your prompting, 8K resolution, training on ArtStation, all these things that kind of make the text-to-image system work better. And of course, like, you kind of have to have this working theory of like, what does the model know? What is it like? It's very technical in that sense. It's very like brittle and unpredictable. How do these things combine with each other? And this is also definitely like a limitation of current methods, but it's also very innate into the training sets and the methods that used to create them. Of course, they're time capsules. You have to kind of understanding when was this data collected? When was it scraped off the internet? What data was scraped? When was the model trained? All these things are kind of this knowledge you need to have in order to wield the systems and things that make them kind of still a bit technical and inaccessible. So now to like critique my own critique, I'm kind of talking about it as like a creative tool, but of course there's a lot we can expect from these outside of the traditional domains of what it means to be a creative tool. Maybe it doesn't have to be a tool in the creative sense. Maybe it's something more for just exploration or inspiration engine. This is a very like, I find important part of the creative process. I think of, like Brian Eno's oblique strategies. How do we kind of form patterns or practices that allow us to surprise ourselves or break away from our current kind of like paths of creative thinking? And maybe it's okay that it's not controllable. Maybe it's just an exploration or inspiration engine. Another lens I think really interesting with talking about these is like, I was talking to an artist who was commissioned, and they were given a commission as a Midjourney output, and they were like, someone commissioned them to make this, and they were kind of offended. They're like, wasn't this is like trained on my imagery, and now it's being given back to me? I think that's kind of cool, though. It's interesting as a kind of like augmented method of communication, of infusing visuals into our communication. There are a lot of things that are hard to communicate, and maybe we can use it as a way to, we iterate with Midjourney, we find the thing we're trying to express, and then we can communicate with it. And lastly, I think these things are also interesting just as cultural artifacts, things that represent, and things that can be investigated or interrogated into understanding, like, well, what is out there on the internet? So there's many ways I think we can kind of, there are a lot of things I think we can ask for from these tools, or from these technologies. And so now I'm going to talk a little bit about my work in this space. I'm going to be sharing 3 tools that I work on. I take the approach of trying to build all the creative interfaces around technology around metaphors. So I'll be sharing 3 tools and 3 corresponding metaphors. The first one is ArtBreeder, and the idea here is like breeding as a metaphor. So these are all images made with ArtBreeder. It was based off BigGAN, one of the GANs that Kyle discussed earlier. And you can see these are images that do not look at all like ImageNet, trained on 1,000 everyday items. These are things that were kind of bred together out of many, many other images through this collaborative interactive process. So here's a little video of kind of like going through an earlier version of the tool. Everything is public and remixable. You can see the lineage for any artifact or image in the system. You can see all the images, like the family tree of it that made it. You can remix it. You can see it's kind of genetic. So you can see there's some like part jellyfish. We can try cranking that up, kind of like CRISPR style. That composed it. We can mate it with another image. So kind of like crossover, sexual reproduction. And then we can apply mutation to it. And so it has this biological metaphor kind of abstracts all these technical things under the hood and give you a very like high-level game-like interface for just creating images in a very kind of like fun, playful way. You can save them. Then, of course, that image then goes back into the feed. Someone else can remix it. So you can imagine it's like, Instagram, a video game, and Photoshop all kind of rolled up into one. And it kind of makes creativity just the act of exploring and kind of like and everything's default collaborative with everyone else. That's at artbreeder.com now. And so basically what that is under the hood is like, it took GANs, which were this like method of turning a vector of images into a vector of numbers into an image, which you can also represent as like a latent space or kind of a spatial representation. And it took that methodology and with this like interface and metaphor made it something very different, something very accessible, where like fundamentally high-dimensional spaces aren't something that we can comprehend, and so it took that into a kind of social-first kind of like crowd-scale exploration of the latent space, and this breeding metaphor made it then very, very fun and game-like. And what I really like about that is like for casual creators, with kind of my background, like people who didn't think of themselves as artists, or they were professional artists, but they wanted more inspiration. They could kind of go on it for fun, and they might stumble into something. And so it's been used by a lot of, all over the internet for portraits, for character creation. People might paint things they find on the platform. And so I got really interested in this idea of like tools, not just for creation, but like almost a tool for before you have the idea, right? For like inspiration and discovery. That you could then use the output as more of like a raw material. So everything in the platform is public domain. It's not about like owning things, right? In fact, it's more like a superorganism that everyone's created together, because every image, right, is mixed from other images, or who owns what. And so ArtBeater takes the approach that like, well, we all own it together, no one owns anything. And so the next tool I want to share is something called Prose Painter. So Prose Painter was one of the first tools that tried to actually take text image and say, what if you could control it? What if you could spatially apply it? And so you can kind of take your prompts and paint them on to the image, and so you can do it in this iterative, layered, spatially applied way, and that kind of gives you a high degree of control over the process. I'm trying to take text image and say, how can we actually guide this in a creative process? And so the metaphor here is kind of like the ink, like you make ink out of text in the same way that like ink making is more technical than using paint. What if you could like, someone could compose an ink out of a certain prompts, like, all right, maybe, negative hippo and soda can, those two prompts together is some really interesting texture. Like one person can discover that, other people can then paint with it. And yeah, so try to make it more of a process you actually develop a craft on, right, or like feel direct control over. The next tool I'm going to share is ArtBeater Collage. This is our newest tool, and this is based in the diffusion methodology. And it's with a similar approach of how do you actually guide text to image. And with collage, you can kind of cut up, you can arrange, this is collage metaphor, and it uses this as the guiding input to this process. So you still give it a prompt, but you also give it an image. And what's powerful about that is the image can be very abstract. It's almost like blocking out the composition, kind of motivated less by like purely generative methods, as like, think about like 3D rendering, where you use your like, your polygons to lay out the composition, what you want, where you want it, what the angle should be, and then of course like the hard work of rendering it, of drawing every pixel in, that's for the computer. And so I'm interested in this like idea of something that's like between generating and rendering, and if you know a good name for that, please let me know. I'm trying to think of one. Where you have, almost like glazing a pot, right? You want to control the composition of the pot in real time, but then, the glaze can be something where like serendipity or surprise can be injected, where the prompt can be useful to render it. So collage is metaphor, it's all remixable, and it allows direct color and composition control, right? How would you describe, I want exactly this, shade of teal in the top left corner of the screen, right? It's not really what text is meant for, and there's ways to hybridize these, I think, in more compelling ways. And here's an example of Kyle using it for some architectural exploration, where of course, like, if you wanted to describe that door, that color, that exact location, that would be very hard, but it's very easy just to draw it with like a little sketch and place it somewhere. And I think this is getting to areas where text-to-image can be used as more of like a more complete kind of a creative experience. So this is really cool to see. Yeah, here's some other examples kind of made by the community, images that have been made with the tool. And so I really think like, you make it as accessible as possible. Like people who didn't think of themselves as artists will create, but also professionals will find new ways to kind of bring it into their own creative process. So just kind of to recap a little bit, like what can we really hope to get from these technologies in terms of kind of creative practice or ideation? And so I think like machine learning is more than just, a traditional tool. If we can think of it as a serendipity engine for ourselves, it has the ability to generate things that I think is meaningfully different from like parametric generation or other types of generative technologies. We can think of it also as like a kind of collaborative connective tissue. Thinking holistically about, the creative process is one that goes from, inspiration to experimentation to collaboration to sharing, and filling out that whole process. And, an art reader, because it has this representation of the GAN, it's not just easier to make things, but it's easier to remix other people's things. Thinking about it not as a tool to make images that you own, but more just as inspiration material that you can kind of consume. And lastly, thinking of it as something that could enable new levels of abstraction in the creative process. So, it comes up a lot like, are you automating the creative process? Are you making people less creative by they can just, one-click generate things? So I try to take a very human creative-centered approach where it's just creativity at a new level of abstraction. Like a creative director who maybe, communicates to a team they're working with, all right, here's what I want. I like this direction. I don't like that direction. Show me more of this or less like that. Are they less creative? I wouldn't say so. They're just operating a different level of abstraction in the creative process. And so I think that's a really compelling system that could enable more people, where you could still guide these systems, but it's about finding the right interfaces and interactions that are most enabling. And a kind of another way I think I like to think about it in terms of this combination of interface and metaphor, and then like how do you turn these raw technologies, which in many cases like GAN or diffusion model, they're kind of just like this raw engine, right? So think about what can we do with these things. And so I think the first step is like, all right, well, we need to build a steering wheel, we need to build a dashboard, we need to be able to drive it, right? That's what some of like the early tools are. But what I think is also kind of inspiring is like, right, obviously you need a steering wheel and you need a dashboard to drive it. Did you use an engine, right? An engine's like a raw technical thing, like a GAN, right? Like, all right, how many layers does your network have? What's the horsepower of your engine? Something you evaluate in very technical terms. And then you have the car, which is like the next layer up. You have your dashboard, your steering wheel. But in the final layer, of course, like you can't use an engine without a dashboard, without a steering wheel. But you also can't use a car without like the whole system of roads and networks around it that make that possible. And so I'm interested in thinking about how these technologies build not just the tools, but a whole kind of creative processes and creative systems around them. I think that's what's really compelling about them. And so now I'm going to lay out like kind of like two sketches for things that kind of I've been thinking about that could be compelling with this technology, and I'll leave it there. So the first idea are kind of like rough sketch for text to image, and the more compelling. Imagine you're an architect, you're working with a client, right? And maybe you don't share the same language, the same terms. How do you communicate? How do you kind of come to a consensus about something? And so the idea here is like imagine you kind of like branch off images. You could the cursors here are kind of like Figma multi-user environment, kind of a very rough sketch, but the client could be like, I like these images. What if it was kind of like a little bit like this? Or what if I could branch options here? And then you can kind of combine text and image and references, and you kind of just iterative collaborative branching. And it's less about like making something than really as facilitating this collaborative consensus process where like, what's the kind of visuals we want for the system, or or half the side doesn't have the same language as the other. Could you use this kind of technology and kind of like collaborative online interface to use it more as a system for facilitating kind of agreement or iteration and collaborative brainstorming? Another kind of rough sketch, like what if it's more like a chatbot? You'd be like, hey, show me some options for how to furnish the space, and it gives you options. Like actually more like this, and use something referential. So it's combining imagery and text together. Could you make it feel a little bit more like X? And I think what's also really interesting is where so you're combining iterative language and guidance and reference imagery. It's kind of more of a dialogue back and forth. But I think what's compelling about things that can inject serendipity without taking the authorship is like, what if it could actually like pose questions back to you using something like a large language model? I think that's a really compelling kind of direction to investigate, where you can understand it. You can spatially, you have now like spatial control, you have text control, you have these many different modalities all kind of coming together. Cool, so I think we're going to leave this with like questions for the other panelists to kind of start conversation. So that was kind of like an overview of my work and some things I'm thinking about. And so to get into questions, I'm really interested in the experience of creativity. I think like if it feels inspiring, if it feels, there's a very personal side of creativity, and that's kind of what matters more than like, is this output? Are you making art? Who made it? I like to sidestep those questions and be like, well, what's the experience of making it? So I guess the questions to start off the conversation are kind of like the feeling of creating with text to image. Like, what feeling do you have while you're making it? And like, what is your kind of like attachment to the images? Yeah, thank you.
I believe for the sake of time, it would be best to move to the next speaker, and we'll skip the first discussion, and we'll collect everything at the end.
Thank you. So we'll let those questions just percolate, and we'll have a little discussion at the end. I'll try to be as brief as possible so that we can have a good amount of time for discussion. So hello, everybody. Thank you for inviting me. My name is Chigozie Unri, as I was introduced before. And as of the end of the summer session that us panelists did in Berkeley, I now work at Stability AI. So among other things, Stability has released an open source text-to-image model, which is called Stable Diffusion. That was designed and trained by Patrick Esser, Robin Rombach, and others at the OMA Lab in an academic context. And as I will talk about a small amount, my background in this world is very much the open source community. You might have been wondering from my bio, like, what is this person with a background in bioengineering doing here, talking to you as though she's an expert in these things? But it's very much the kind of creative outsider role, as I think Carl talked about. And so for that part of that reason, any views here that I'm expressing, they're kind of my own, rather than necessarily Stability, which I've just started working for, though of course they've generously supported me to be here and spend time skiving off work. So I'm here to talk about what might come next for text-to-image. And I say text-to-image to kind of locate us within the broader space of generative history that Carl talked about. Though it's not necessarily clear that text is, in all cases, the most expressive input, nor that necessarily static images are the most expressive output. So perhaps I should rename what's next for thing to thing. And the future is hard to predict. I don't say that simply as a general truism, but because in this field specifically, things are moving so very fast. Whenever you personally heard about AI art, it might have seemed like it rapidly came from nowhere, and that's not just because you hadn't necessarily been paying attention to the right things, but because it really is moving and accelerating very fast, to the extent that the number of papers in ML is a good proxy. We're seeing a doubling time of something like 23 months. That's not necessarily the best proxy, but archive papers are at least some way to get a handle on things. And also from a subjective view, from the inside, it certainly feels like in this last little section over here, a new model might come out every day or every week that it completely resets my expectations as to what is even possible, something I didn't even expect could be possible. And some of those examples you'll see here might have come out in the past week. So in this context, even viewing a month out seems fraught. So the approach that I'll take here is to survey projects that are in maybe a prototype type stage that hold promise. And in particular, I'm going to focus a lot on what I'll refer to as inference tricks. I'll draw a general distinction between innovation here in the foundation model space and these inference tricks. On the one side, for the underlying models, often training is very expensive because they require large data sets, which people might not have access to, and lots of compute. So for this reason, training these models is generally restricted to large companies or maybe academic institutions that have sufficient funding. When I refer to foundation models, by the way, I'm using a term that's popularized by the Stanford Institute for Human-Centered Artificial Intelligence for one model that is trained on a huge amount of data and adapted to many different applications. In the image context, that might be opposed to, say, training a model specifically on celebrity faces or the MNIST numbers dataset, or cats or dead leaves, that are very specific context. On the other side, inference, which is the step where the image generation actually happens, is far, far cheaper in terms of compute. So innovation in this space might be possible for it to come from unexpected sources. It might not need training at all, any training of a new model. It's just individuals working in the world. And the barrier is not as impermeable as I'm making out. Some techniques that kind of originated on the inference side can cross over back onto the training side, as can some individuals. So myself, I kind of, as I said, started out in the open source world. Now I'm working for Stability. And in my view, one particular benefit of open source models is that they accelerate the feedback between these different approaches. As Carl mentioned earlier, because things are available, that allows individuals to make innovations, and because there are so many more people out there in the world trying and experimenting with things, that just makes a multitude of ideas, new ideas, possible. In fact, the whole approach of clip-guided image generation, which is a trick in itself. It's taking pre-trained models and assembling them together in a clever way. CLIP was pre-trained. The unconditioned image generation networks that you attach it to, they were pre-trained, and you can put them together without requiring necessarily a modification of weights. Though, of course, to then progress that further and get better image generations, you then might want to train new models which kind of use the knowledge embedded in CLIP later. My own kind of small early contribution is also a trick that is almost entirely on the inference side. So it's eliciting animations from a network that itself only knows about two-dimensional static images. So you generate one single static image, you warp it in some way, maybe an affine transform, a rotation, a zoom, or whatever, and then you feed the result back in as an initial image, and then you can generate these camera movements through a space, and maybe if you alter the prompt as you're going, you can get warps and changes that bring a new ability to a network that requires no training. This approach was later expanded by my now colleague, Adam. So he added three-dimensional warping in between each phase, again, not training any new networks, but assembling existing ones. And this particular video, it's what he regards as a failed test, but then it accidentally generated 4 million views, just because he put it together and released it, and then all of a sudden, wow, people were excited about these things. And the first time you see them, it's incredible. And every time you see a new thing, wow, how does this work? So following here are some exciting experiments, recent experiments from artists and hackers in the space that don't necessarily require any training at all. Paul Trillo has been making really excellent videos using in-painting on video footage. This one is a relatively architectural example. It uses DALL-E and After Effects. So it's putting together existing tools, no code necessarily required. And I think this in particular illustrates how the eye of a director, of somebody who's already a working artist, can elevate this as an art form and really and it's why I view myself as creating tools primarily for artists, although of course it's incredible and great that people can use these tools to generate things that they've not been able to before. But an artist's eye is really necessary to have the kind of artistic vision of, okay, I want to create this, and this is going to accelerate my process, but it doesn't replace the artistic vision in the first place. It merely supplements it, which we can maybe talk about in the discussion section. Another in-painting example, which in this case requires a little more code, but still no modification of the underlying networks. This is from Scotty Fox, who's been very recently doing really exciting work, taking 360 or spherical camera footage and then projecting it onto a flat surface using in-painting to change it, or image to image to change it, and then reprojecting it back onto the spherical footage, which gives you this like almost real-time AR-like experience where you can edit the surfaces of the room and you can still interactively move around the room, and maybe something generates, it takes a few seconds, and then you can look over to it. Apart from the inherent coolness of this demo itself, it also kind of fakes the real-time aspect, because the generation still takes a few seconds, but it's still interactive. And so this gives a taste of what might be possible when we can improve the inference speeds by maybe an order of magnitude, to get into the realm of real-time generation, where you might be thinking about real-time generation in terms of video games. I would regard that as maybe 10 frames a second before it really starts to feel like, okay, this is really happening as I'm generating. And I think once we hit that point, there will be, it's not just a quantitative shift in generation speed, it also allows a qualitative change in the abilities of networks to be used. You can also use something like a rendered 3D environment rather than video footage as your initial imagery. This is by my friend Euclidean Plane, and this is using Disco. And in that case, you could then reproject any textures back onto the three-dimensional scene to be used then later as decals, which, and then you can look around to the newly rendered textures. This also leads to what I think is a really exciting possible pairing, which is neural radiance fields. So if you don't know what a NeRF is, maybe you can think of it as a souped-up machine learning-powered photogrammetry. You can take a few views of an object or a scene, and then using that, you can render novel views of that scene. Unlike photogrammetry or traditional photogrammetry, you don't go via estimating a mesh in a textured object. So this is then a very natural pairing with image-to-image applications. So this video is literally yesterday by Bilawal Sidhu on Twitter. He also has a popular YouTube channel. So I'm very excited about this possible pairing. I'll now move on to approaches that maybe require a little bit of training, but have a lot of bang for their buck, maybe not, and maybe don't require as much as a brand new model. And this will also illustrate the interplay between researchers and open source and kind of hackers doing things. So one thing that's recent, Dream Fusion, is a recent paper. It's by Ben Poole at Google and Ajay Jain at UC Berkeley and some others. And it uses Imagen, which is Google's text-to-2D image network. But it doesn't require any other training data to render three-dimensional NeRF environments. This might be surprising because you might think, well, I've just got all these two-dimensional images from the internet in my training data. I don't know anything about 3 dimensions. All that my foundation model is trying to do is predict what's the optimum, the best predicted output for what this pixel is next to this pixel, and it doesn't really have any other spatial information. But this is why I said at the beginning that the foundation model might encode some hidden information, if you'll allow me to abuse the term, that like latent hidden information. It's not quite the same as latent space, but about the world that can only be kind of elicited from the model by a sufficiently clever technique of, in this case, going back and forth between the NeRF and the 2D model and ending up with something consistent. And in fact, that paper explicitly invites people to sub in other models in place of Imagen, which is not publicly available. And so only 6 days later, Jiaxiang Tang, who's a PhD student at Peking University, had subbed in the open source weights of Stable Diffusion to produce what is admittedly a more limited replication of the results. And so that's why I'm saying that having open source is really acting as an accelerant for what people are able to do. And yeah, so, and I also thank Ajay and others on this paper who kind of provided the pseudocode, explicitly invited people to sub in other things. Another very similar trajectory is Dream Booth. So as Joel described, you might want more control over the subject matter than just a simple text description. You might have a specific object in mind. I want this dog, my dog, to be represented. Here I'm going to kind of unfortunately equivocate between two similar papers. They were both released in August 2022. So one was textual inversion from Gala et al. From NVIDIA and Tel Aviv University, and then Rees et al. From Google. Both are quite similar. They provide the ability to provide a few images of a subject or maybe a style, and then use that previously unknown to the network object as a token in your text prompts. So for example, the dog in these scenes in different styles, or maybe rendered from different viewpoints, or in different contexts. This is distinct from fine-tuning, which pushes like every output of a network to be more like the images fine-tuned on. So you might want a pixel art trained model, for example. And it's also distinct from just pure image-to-image, which uses the general structure of the input image as Art Breeder Collage did, but it doesn't have necessarily any semantic sense of what the context is. It doesn't know that this is this dog. And then, much like Deep Dream, you might end up with dogs rendered in strange places that you wouldn't expect. And like the Dream Fusion paper, Dream Booth was based on the Imogen network, but because the weights of stable diffusion are available, then third parties were able to sub in that network. And this has led to really an explosion of people training, for example, personal concepts of their own face. This is the most immediately tempting thing to do. Everyone wants to kind of have a reconfigurable machine-interpreted selfie machine. But really, you can teach any concept that may not exist in the original data set, or point to a very particular part of the latent space that might be difficult to disambiguate just using text. Because the tokens kind of overlap with other different contexts. Again here, the weights and code being open source acts as an accelerant in much the same way as Google Colab, providing compute, has acted as an accelerant to open source people being able to do things in the past couple of years. And Hugging Face maintains a library of published Dream Booth stable diffusion concepts that other individuals have published, which you can browse and use, or you can train your own. It's very simple to do using Google Colab, so that if you want to have a building that doesn't exist in the data set and render it in someone else's style, you can take some photographs of it, train your small specific model, and then use that in this style. One very final example, just last week, Google released Unitune, and the week before they released Imagic, and these are both papers that can allow some similar kind of content-aware image editing capabilities using, in this case, just a single image and a few minutes of training. And then moving back to things which actually do require full retraining on new data sets. This case, though, I wanted to include because I know many people are excited about it. So unlike the disco-style animations, which I mentioned at the beginning, which can be applied to any text and image to static 2D image network, full text to video does require some time component in the data set, which, as far as I'm aware, doesn't exist in just two-dimensional static image data sets, unless, again, somebody might find a fantastic way to reconstruct it that is just hidden right now, and maybe that's waiting out there. There are currently not many examples of this full text-to-video pipeline. So Cog Video, which is trained in Chinese, is available, but these other ones here from Meta and Google, they've published the papers, but they've not released the weights or the code. But some of those ideas may be able to move back into the open source community. They just need the training, though. So any one of these experiments that I just showed might grow into the next big thing. And also any new foundation model, thank you, might be the next big thing. Until just last year, basically, GANs were the most promising approach. Diffusion was an invention that was, as Carl said, kind of 2015 to then 2020. It really got going, but it didn't seem like it was going to be the next big thing. And similarly, transformers were an invention that completely changed everything people expected machine learning to be able to do. So it's possible that the next thing won't even be diffusion-based, and I've been talking nonsense this whole time. So to summarize, new capabilities and ideas can come from relative outsiders, including you if you're working as an artist, an architect. Maybe you just tuning the knobs or like pushing them beyond their boundaries somewhere, even without knowledge of the underlying internals of the network, might lead to the next big thing. And also providing models and code in an open source way, I think acts as an accelerant to artistic expression. We've seen that since the release of Stable Diffusion just a couple of months ago. There's really been an explosion of things. So my questions to the rest of the panel, again, just as a thing to percolate, what do you think seems not possible right now that might occur in the near future, and what seems easy right now that actually might be harder? Maybe some of these things I've presented as ideas might just not work out at all. Thank you very much. Thank you for inviting me, and we'll get to the discussions.
Well, thank you very much. It was very, very inspiring, and at the same time, it's daunting to see how the technology is actually growing and what it can do in the near future. So we have a couple of questions. We can dive directly to the questions. I believe some of you who've posted these questions might be among the audience. Theodora, are you here? Yeah, okay, so maybe you can ask your question. The microphone is actually coming. And Danielle Kohler. Yes, Dan is here also, so we can also have another microphone there.
Yeah, well, thank you. Just absolutely incredible. I'm just kind of still digesting. I kind of rushed to put the question in the Slido, so it was triggered by Kyle's kind of introduction, and it's kind of completely blind to all the awesome, amazing things that you kind of showed. It was a very kind of broad question about the kind of stakes of calling machine learning AI. Does it kind of bother you? But it was also kind of a question that maybe kind of speaks to Kyle's kind of historical overview, kind of thinking about just kind of the foundation of, you know, the term as kind of deliberately breaking with a kind of tradition of kind of modeling the brain and kind of thinking at more kind of engineering experiments, kind of materially embedded experiments, and kind of, you know, pushing AI towards kind of symbolic abstraction and science and the mind as this kind of abstract entity. So, and the kind of ideas that AI would sort of be a cognitive kind of intellectual project that would help kind of decision making and so on. So in some ways I thought it's interesting the way that you also talked about kind of creativity and the kind of like value of the work as really being placed in kind of the experience. Like I was thinking, is there a kind of historical reclaiming of that term, or are there kind of issues in kind of using the same term that negated the things that you're kind of trying to do now to kind of describe them? And then the kind of more question about kind of rhetorics, kind of whether, because like a lot of the amazing stuff in your presentation comes from this kind of technical like specificity and like really working with the terms and the models, and like whether these kind of broader umbrella terms end up being kind of distracting or, you know, confusing research and the public and so on. So yeah, any kind of reactions, but that was kind of the, yeah.
I totally have a take, but I'd rather you guys start.
Yeah, I can start off. So obviously, artificial intelligence is a very loaded term, and we tend to think of intelligence very much in our own context as human beings, where we have a certain way of doing creativity, a certain approach that we take, and that might be very diverse. But the kinds of minds, if you will, that a machine might have are very different architectures that people have tried for a long time, and kind of it's very tempting to think that, well, if you just train something that has the capabilities to make images like this, or any of the other multitude of applications that AI is being used for, that then it must necessarily teach us something about the way that our own mind works. But I think that that's not necessary at all. And in fact, if you look internally into things, it's a very alien representation. And there might be metaphors that you could draw between the way that a machine, again, thinks versus the way a human thinks. But it probably isn't the same, and I don't think that just throwing more data at it or throwing more compute at it will get you to the same place. However, I think it's more interesting to think in terms of capabilities. So, like, what do these systems allow us to do? And even if that system was just a lookup table that allowed you to kind of more quickly find the information that you want, that equally is an accelerant. Like people have been externalizing their minds to books and all sorts of external artificial tools forever, and that it's not a lookup table. That's like generally when people see these things for the first time, like often you might think, oh, it's cutting up. It's going on a search for Google and it's cutting up and it's finding a picture of a dog and then it's finding a picture of a cat and it's merging them together and then it's doing some kind of Photoshop filter over the top. And that's completely not how they work. But frankly, the input and the output is really the important thing. So you can talk about whether artificial intelligence is the appropriate term, but I'm more interested in like, what can it do for us? What can it do for our creativity? Yeah.
Yeah, I can talk about the terminology a little bit, because something I've struggled with. I tried boycotting the term AI because I really hate it. It wasn't very successful. It's definitely worth, I think, commenting on it in terms of like the use of, I mean, these models are very much products of like big capitalism, and hype is a part of that, where a lot of these corporations use AI as part of like the hype cycles around them, which can be very misleading to the public, like, oh, it was made by an AI, and that it has all these kinds of like connotations to it that I found very distracting. But saying like large generative models, machine learning, these terms are less communicative, so I guess like going back to like, you know, Wittgenstein a little bit with language as use, sometimes I've now found in order to communicate with people, you have to meet them where they are, and saying AI, they're like, oh, okay. So like so there's a little bit of a balance there where like that's kind of how they see it, and sort of communicate. Sometimes it can also be more clear to say like it's made with AI, and people are like, oh, okay, rather than like diffusion model, which doesn't mean anything to anyone.
My take is very similar. I would love to have, now I'm thinking about my presentation and what I said. I don't know if how much I use the term in what context, but I find it to be a distracting term, and I try to use terms that are more specific to the technologies that we're using. AI as a pursuit of artificial general intelligence is so separate from like the kind of work the kind of tools that we're working with here. They're as separate from that as, you know, scanning a banknote and understanding human handwriting and translating it. It's more operating on that level, and the rest of it is used for sort of hype purposes.
And I think I have seen people try to move towards using generative art, but again, that doesn't necessarily distinguish between the very kind of formal rules-based systems that right. you could write down the algorithm on a piece of paper versus what we're doing, which again is in the same tradition.
Yeah,
I think
maybe that's a good idea to bind it to that tradition.
Yeah,
is probably a better tie.
Yeah, I mean, all of the kinds of computational creativity things that we were doing. You didn't mention processing, but I know you were kind of planning to. Yeah, those kinds of traditions, I think, is very much the kind of hacker culture that this comes out of, and this is just, again, it's like a matter of scale.
Great. So with that, should we move to the next question then?
Yeah.
Great. Go for it.
Yeah, hello. Thank you for your wonderful presentations. I would be interested to hear about your experience about new emerging cultures of creativity or cultures of making. Like, there's not by coincidence, Midjourney uses a Discord server which would allow for massive collaborative image synthesizing and so on. Does that really happen? Or what is your experience with like new modes of really being creative? So not seeing a machine just as a canvas and the human, or not having this division, or like, would you speculate on new forms really of being creative or making? Do you see there some windows in a way?
I'm tempted to start with how we met Joel. I met Joel, I think I was following him on Twitter or something, and one day he tweeted something to the effect of, who wants to come to a land GAN party?
Land breeder GAN party.
Land breeder GAN party, which was confusing, which was an event that was hosted at Stochastic, which was a party in which everyone who attended was simultaneously kind of working on GAN breeder, not art breeder, right? GAN breeder at the time, and it became a kind of social event, sort of community of, of making together. So I think it's like maybe a starting point, one kind of example of the sorts of things that y'all are interested in, maybe not live events, but fostering those kinds of communities.
Totally. Yeah, I think I see it very much connected to like the rise of like internet cultures and a lot of creativity moving to some of those social domains where, at least in my experience, like Art Breeder was founded as like a place both to like conceive ideas and share them and remix others. I think you're seeing it now with like the increase at many scales, like the communities that are building the tools are very collaborative, and like the ability to just, that we're living in these social platforms, like some of us like our whole lives are in them. So it's all kind of in this one environment where like socializing, brainstorming, collaborating, it almost becomes like a lifestyle at that point. And so it feels just much more natural to, and I think for me, like also as in some cases, like the creative practices get more technical and they involve more tools, I think like the role of like citation and accreditation will transform, like, and it'll be less of like, lone artist and more, I came from, research lab, or like on a paper you have 30 citations, and that's kind of normal because it's very clear that like the amount of technical work needed for your advancement, and I think with something more like technical creativity where there'll be a lot more kind of like citation and accreditation and kind of default collaborative rather than default like solo creator.
So I think for me personally, I guess the reason why I've ended up drifting into this world further and further is because of the community. I wanted to create some specific piece of art, and then I built the tool to do that, and then I published it, but then keeping within that world is really is as a result of people then wanting to use that and to kind of play back and forth between like somebody develops this new thing and you're like, wow, that's cool, that gives me this idea that I can do this next thing, and that does happen, as you said, on Discord. That happens with specific images that like somebody might see a prompt going past and they're like, wow, that's cool, I want to adjust it in this particular way. And it happens with technologies as well. I think also going back to Joel's question from the presentation about how does it feel to create with these tools, because I think that's relevant. There's kind of two modes that you can operate in. One is that you have a specific artistic vision that you're going for and you want a particular output, and these can help with that. But also, because there's such an abundance of beautiful images, sometimes it can feel more like the artistic process is a process of discovery. And in order to do well in that process, you still need an idea of what it is that you want to create, or like what you're trying to say, to be able to navigate through that space of like abundant images and say, yes, this is the one that I want to present to the world. But it does feel a little bit different in terms of creativity, and doing that in a collaborative process also is helpful. It feels kind of like a game to find like, okay, where's the beauty that we're going to find today?
Very good. Adam, are you here? Great. You want to ask your question? I have myself some other questions, but for the sake of time, I would rather, for the audience, I'll keep it. But it would be related to the modes of communication. We're talking about text to image. Why text to image, right? Because is this the same language because we're writing programs or communicating? Or there can be other forms of communications with computer.
Okay, so yeah, let's answer that and go to you. So text is an interesting one. Obviously, we often, again, as humans, we think in text, we communicate in a verbal mode of communication, and that's where many people are very comfortable. It's not the only way, but it is specific to your own language. It's specific to the culture you're in, and also when you have a relatively short prompt. I mean, there's a distinction between prompt minimalists and prompt maximalists. Prompt maximalists might put all of those different words that Joel put up, the trending on ArtStation HQ at 360, Pixar, Canon, whatever. But those don't really add semantic context to what it is. But it's interesting, actually, if you look at some models which were trained in other languages. So, for example, Rudali, they have a very good model which was kind of, again, based on the architecture of DALL-E, but then trained in Russian. And it's interesting when you try to get good results out of that, you can't necessarily just auto-translate. Because if you want to put in the name of a person, for example, you have to think, okay, well, do I transcribe this to Cyrillic? Is that what's going to be in the data set? Or is it going to be the name of the person in Latin characters? What's the cultural assumptions going into this? What do I expect about the data set? And similarly, other networks have different cultural assumptions embedded in them. And when somebody trained a fine-tuning of Japanese stable diffusion, and it's interesting because it's not only the language of the input that changes, also all the cultural assumptions that go in and the kinds of images that you get out were different because the data sets were kind of culturally confined. So using text is fraught in that way, and kind of you want to be able to point specifically to the part of the latent space that you're referring to, and that's why we're talking about there are these other ways of telling the network what it is that you want to do.
It's actually bringing up the sort of sub categories of stable diffusion. I think it's actually a pretty good transition to the next question that Adam has about open source. But before that, really quickly to respond to the idea of text, I'm really interested in the. I know Joel is bearish on text as an interface. I'm interested in the kind of the way that this changes the landscape of expertise in this particular design activity, where, thinking back to the rise of parametric modeling, those of us in the community that had analytical skills and could break down problems into smaller problems and kind of work them out, had an advantage when working with something like Grasshopper. Who has the advantage in the community when working with text to image? It's the culturally literate. Right? It's people who have good vocabularies, who took an art history class. Those are the people who are advantaged in the situation, which I think is kind of nice. Adam.
Great. Thank you for organizing such a timely and important panel. I feel super fortunate that ACADIA made space for this year. And also I really appreciated, Kyle, your kind of intro, which I think both captured the kind of deep historical basis of this work, but also I think accurately hit on the kind of moment of paradigm shift that we're in right now. So my question is really, I'd love to hear our guests kind of unpack some of the ethical questions surrounding this work. And specifically, I mean, I know in industry there are questions about, intellectual property, et cetera, but I think what I'm more curious about is, as we know, the kind of tendency for technologies to be co-opted or redirected, let's say, towards more sinister ends, right? And I'm thinking here of deep fakes, misinformation, et cetera. And I come at this also as primarily as an educator, so thinking about how we can create the space for our students to engage with these amazing tools, but in a kind of critical and self-aware way. I'm also thinking, we're literally the day after Twitter has just been acquired by the most, the wealthiest person in the world, and wondering how we might try to kind of preserve the vitality and the excitement of this work in this moment right now, while maybe resisting like the dual tendencies for these technologies to be, let's say, more kind of centralized, maybe sliding back a little bit into the history that Kyle walked us through, but also, as we've seen in this country and elsewhere, kind of the flip side of kind of open source distributed networking to enable kind of darker things. So it's a big question, but I'd love to hear your thoughts on it.
That's an important question. Thank you for that. And it's a tough one. I can make some observations about different approaches that I've seen, that I see out there in the world. I think that if there were two poles being taken by institutions that have the power to make such decisions, it would be something like a kind of radical libertarian approach. This is a tool put out in the world. People are going to do what they do. They'll do bad. They'll do some good. On the one side. On another side, there's a kind of walled garden attitude. OpenAI offered trainings and orientations before you were allowed to use the tool. It was completely closed. It was invitation only. You had to go through orientation first. And they also responded to criticism of a lack of racial diversity in the images that were being produced in a pretty ham-fisted way, in my opinion, where they were injecting new terms into the prompt at the end to ensure gender and racial diversity of the images that resulted, which produced some sort of very silly images in the end. So well-intended, but I think it illustrates the difficulty of dealing with this problem. I don't know what will happen. I can say what I hope will happen is that, like the invention of Photoshop, changed the way that we look at photographs and makes us more skeptical as a citizenry, let's say, of what we see. I hope that we might develop more sort of inoculation, skepticism, literacy in these methods. They are in the world. No one on this panel, sadly, is empowered to make the decision of removing them from the world, or even really say with any kind of authority how they enter the world. But from my point of view, this is sort of the best we can hope for in that way.
So I think...
Anyone else want to jump on the landmine?
Yeah, so I think that they are certainly important questions to ask, and it is, as you say, timely. I think for open source in particular, one of the things, you have to weigh up what is the benefit to releasing something, which I think is vast and great, versus arguments that people have made that there are powerful ways that you could use it, which you wouldn't necessarily want people to do. I think for each of those abilities, where you're talking about deepfakes and things, those things are possible to do anyway. And so, again, it's maybe you want to try to allow people to do the great and creative things that they want to do. And I think the point that I was making in the presentation about the reason that open source is good is because people can do creative things. Also, one thing is that when you release something that allows people to be able to investigate it and look into the biases that are inherent to it, that the person who originally trained it might have overlooked, and then be able to further mitigate those. Yeah, does anyone else want to?
Yeah, I got a little more. I totally agree with everything said. I think it's been interesting this summer where, at least Silicon Valley, there was this kind of culture switch between the two poles Kyle mentioned, the kind of libertarian versus centralized, and like the centralized way had been winning. OpenAI kind of like controlled this technology and didn't think anyone else ought to have access to it. And as they were kind of making that moral argument, they were like raising prices on the access. And you kind of saw, as Stability released their model, there was this kind of like culture shift in the Valley that I thought was really interesting this summer. Where suddenly like the claims of OpenAI kind of rang hollow because they were doing it as they were kind of like rent keeping this tech. And then when they did release it, there was this like flourishing of creative work on the internet. And I think that's, at least in the view of many in the Valley, reinforced this kind of shift back toward the kind of libertarian approaches, having seen what happened, where the release of this GPT-3 and DALL-E 2, the positives are thus far, in the view of many, widely outweighed the negative.
For sure, the techno-libertarian position is the default position of Silicon Valley. So that, I think that the walled garden position of OpenAI was an anomaly, if anything. Yeah.
Thank you. Thank you very much. There are other questions that Jose and Gabriela. One thing that I should mention, and we did not probably emphasize enough, obviously machine learning methods as a generative tool has been used for the past couple of years in the field of architecture a lot, but we are reducing the scope of this conversation, this panel, to text to image.
Should I? Yeah. Thank you. It's been a pleasure to hear you speak. I was thinking about machine learning. Well, my question is really addressing the data type of the image as an output and wondering how much of that is, how do I say this? Like, how do you see advancements in other data types and that could be maybe more adequate to a design application, for instance? So like actual geometric data, whether it be meshes, graphs, or analytical representation of geometry in BREPs and so on. So do you see, like, is the proliferation of this image-based world just made easy by the fact that the web is full of images and the data is just there? Or do you think there could be another spring for other data types as well? Thanks.
So diffusion in particular is actually quite agnostic as to the output that it wants. There's been some very good results. Dance diffusion, again, that's something that Stability is doing for audio, but also biological data and things. As far as just pure geometric data or things where the output is like a very small number of bits, you might be better off with other approaches, I'm not sure. But you certainly could do things like generating an image again, but then translating that into outputs when you're talking about like inspiration, or you could also automate that system. Going directly to those kind of data types, I think is perfectly possible. But again, it might just be more fruitful to use smaller, simpler systems that are specifically designed for that. However, what I think we've learned continually is that throwing more data at things and making the capabilities of a single model bigger and better can often outperform the person who's going and working on their very specific application, and they train the model just for that, which is kind of frustrating often, because it's like, well, why was I doing that? When this person over here is doing GPT-3, which has like all of these different surprising capabilities that nobody would ever thought exists, or image models or whatever.
That was my answer to Chia's question about what seems easy today that will actually end up being quite hard. It would be polygon meshes as an output. I think that either won't happen or we're far away from it. Bold prediction.
And not just polygon meshes, but also things like rigged models, right. And that sort of thing, where you have, like, again, you have to have some semantic understanding of what the content is, rather than just mimicking the visual style of something, or mimicking the sequence of events that happen.
I definitely think image and text are going to reign supreme for the foreseeable future. There's like the big question for a lot of research now is like they've sucked up all the images and text that exist on the internet. And they've really trained on everything that's out there, and they've kind of gotten the gains they have because of that. And like, it is a big open question, like, well, what happens next now that all the data has been sucked up? So in terms of things we can't predict, like, I think the advances in like synthetic data, or ways of reducing things to text, will be kind of the area that will unlock those new things.
But personally, a lot of the generations that I love to do are like purely geometric things. And it's almost interesting because there are imperfections in them. You get a geometric design, but it's as though maybe a person's drawn them, where like rather than digital art kind of geometric designs, where it's a purely vector thing that's totally perfect. Yeah, I do enjoy making those kinds of outputs. And I think also those are valuable outputs to try and make rather than just doing, like, what people tend to do a lot when they start is they make the concept art fantasy style outputs, and then you get a lot of those outputs which are beautiful, but there's more in the models that you can find. There's curious, interesting, different parts of the latent space that do something weird that you won't expect.
One last point on that, I think it's like, there's also like the framing of it as like generating the artifact, like make a whole 3D mesh or like a 3D model, versus things like throughout the process where machine learning can be evolved, or like during each step, where almost like during the brainstorming, the concept planning, each decision, where you could break it down rather than framing it as like, all right, just spit out like the final artifact as like a conceived whole.
Yes, I think that was the point of two other questions that was in the list, actually. Thank you for responding to those indirectly also. How's
Yes. Am I here? Yes.
Yes.
Hi. Well, thank you very much for the panel. I'm absolutely mind blown and deeply reconsidering what I'm doing with my life and my career. So I guess I just want to ask the panelists, what do they think about how all these models and all these techniques may make us reconsider the notion of craft? In my opinion, craft is something that we typically associate with forms of art that have a very strong relationship between the author and the tools that they're used, and it's through the mastery of those tools and the empirical experimentation with those tools that the notion of craft arises. And I see in these models a lot of traits that are similar, the idea of exploration, discovery, learning things such as a natural language like Joel was describing before, and things that you learn more as opposed to analytical processes or engineering-oriented classes. You learn more from like the guild that you belong to and the people, the learning that you get from. So do you see these models as being the new form of digital craft, or because we tend to associate craft with old ways of doing things, is it going to be going back to rule-based generative form making? Is that going to be now the new craft because we just have these new techniques? Where do you see this going?
Well, so I should say so the stochastic residency proceeded through dinners and wine, and the subject of conversation at many dinners with wine was this subject in particular, craft, and how these new practices relate to ideas of craft. But I would take issue with the second part of your question, that craft, for me, doesn't simply mean that it's older. So generative design, like rule-based making, let's say in architecture, is a bit older, and it's maybe the kind of, you could see it as the thing that came before this. I don't think it'll be displaced, and I'm actually would like to pass that to Joel and his interest in generative design as a complement to this kind of work. But going back to craft for a moment, so to me, craft is a kind of embodied relationship between a maker and a set of materials that is not intellectualizable, right? It proceeds through tacit knowledge. So you learn how to play something or work with something, and it's not something you can intellectualize. I do think that tools lend themselves differently to craft-like processes, but it's not just the inherent nature of the tool, it's also the cultures that grow up around it, and it's also the player, right? So any player can play anything, right? You can play a kazoo and become a master at the kazoo, but the kazoo resists craft-like behavior because of its sort of thinness, right? The more you invest in the kazoo, you don't keep getting further and further and deeper notes and more sort of elaborate, I don't know anything about kazoos, but you catch my point, right? Like there's a reason why things like, I don't know, violins have concertos written for them and kazoos less so, right? And it's not just the instrument itself. That's one factor. Culture is another big factor. Violins are valued because of a Western tradition of classical music, of course. So how does this new tool fit into that? I think is a question. There's a paper that I think I've now waited too long to write. It was going to be titled "Midjourney is a Kazoo," and it was a criticism of Midjourney's assertiveness in its aesthetics, or in comparison to other tools, which I think makes it in the end a very thin instrument. But I think that's actually changed, and it's too late to write it now. So I think that is a central issue. Like, how are we going to play this, and how are we going to build up cultural structures around it that enable deeper modes of production? I think that will happen, but I don't think it's a matter of displacing generative design, for example.
Yeah. I would like to say that I think it absolutely is possible to develop expertise in making these systems do what you want. The people who are doing the best, most exciting work, you can instantly tell that a particular piece of generated art, even if it's not going back and forth with image to image and in painting and something, even if it's purely text, people have really quickly developed their own styles. And again, the people who are best at doing that are the people who already have an artistic background and an artistic vision of something that they want to say.
Just I don't mean to interrupt, but to tag on to that, you've been watching, I think, probably what's behind us, and as I was putting that together, and thank you to everyone who gave images to it, it strikes me that what you just said struck me in that it's very easy for me to tell who made an image before the name appears. And I don't know if you guys feel the same way or not, but there's definitely a possibility to develop a voice in this medium. And that's evidenced by, you could guess, that's Ron, I think, on the right. Is it? Am I right? Andrew.
No. the one time. But
I think final thoughts, because I think we're over time.
Oh, okay.
Yeah.
I could jump in. I think it's a really good question. It's definitely like the basis of all my work is how do you facilitate craft? How do you turn these technologies into tools? And I'm skeptical of something like pure text to image is something that has the kind of depth to facilitate that kind of craft-like process. I think it's worth noting, we're in such the early days of these technologies. You kind of saw it happen with GANs, where there's this kind of newness to it that made it compelling. And then over time, you could kind of see, which artists were still working in this field years later. And I like to kind of look to them as kind of the people who are pushing the frontiers of what craft could look like. And we may not, it may not be the craft in the way we think about it. There's certain artists who are very good at a certain process of collecting and curating data and trading models on their own work. And there's obviously a big craft to that process. They create work that's extremely unique and personal to them. But I don't think we maybe think about data collecting as something that could have craft to it, but I think some of these early artists who are kind of pioneering this. And so once these different tools are able to kind of work together, and she kind of working there's an artist, Claire Silver, and seeing how she used these tools was really inspiring to me. She might use 6 different tools together. She didn't just take Midjourney output. She took Midjourney, she took Artbeater, put it into Midjourney, put that into Collage, took all that back into Procreate. It was a very involved process, and seeing these tools in a really craft process, there's an assemblage of tools that work together. And so I think seeing some of these cutting edge artists, I think give us a nice insight into where the craft will develop.
Well, we're running over time. I'm sure there's many questions for our speakers. Thank you very much for your contribution. Really great conversation. And by the way, this is a fantastic prelude to what is going to come next as the next panel that Hina put together this afternoon after the keynote speaker. So I'll definitely encourage you to attend. And in the meantime, during the lunchtime, feel free to reach out to our speakers to ask your questions a little bit more in detail. Thank you.
Thank you.